Hi everyone, this is James from Stealth. For those who may not know, Stealth is a cryptocurrency. It was launched in 2014. It was launched with mining, so it was mined fairly by the standards of the day, meaning the coin distribution is fair. Soon after mining, or right after mining, it went to proof of stake, type of proof of stake that people may be familiar with peer coin. It's been proof of stake since then. The focus of the coin when we launched it was to be a privacy coin, and so it was launched with privacy features. It was it was the first proof of stake coin to have a built-in Tor network, which was a kind of a important point for the day, but these days may not be considered that significant. But it was cool for the time. And then since then we've done a lot of protocol improvements. We've added some privacy features, and we tried to make the blockchain work very well. So the blockchain has always been in very good health. It's always been one of the most highly, you know, connected networks on Bitrex and so forth. We were on Bitrex shortly after launch, like a day or two, maybe 3 days. We were on Bitrex, and we've been on there ever since. And we're on a few other exchanges. Today, I'm going to talk about what we've been doing and where we are with what we call quantum proof of stake. So, to give a little background, Stealth, after privacy and after we got going in the last couple of years, I'd say since sometime in 2016, we really decided to start focusing on three big core aspects of blockchain, like the big three. The first is a usability, from an end user perspective. We know that end users don't want to learn anything technical. They have busy lives. They already know a lot for whatever careers they have or whatever it is they do. They don't need to learn technical stuff just to use a cryptocurrency. That's not the point of cryptocurrencies. So to that end, we got on Ledger and we've been developing some wallets that people can use without having to download the blockchain and so forth. The other things that we wanted to focus on is privacy, which has always been the focus, but we really wanted to set our privacy solution apart from the others, and with that in mind, what we wanted is a privacy solution that was on top of a high performance blockchain to really create this technological novelty. We believe the combination will be groundbreaking because there are no blockchains out there that we know of that support high performance transactions with cryptographically private transactions. And so what do we mean by cryptographic privacy? Cryptographic privacy means you can hide the sender, the receiver, and the amount of the transaction. That's total cryptographic privacy. So nobody knows who sent who and how much. You can't ask for anything more in privacy, and that's what we want to put. But the challenge here is getting it to where the blockchain is super fast. So what's a super fast blockchain? We're talking about, rather than like Bitcoin that takes 10 minutes on average, or has a target of 10 minutes to confirm a transaction for people to know that their transaction went through. That's what confirmation means, that you know your transaction went through. Rather than that, we want it in several seconds. And there are several different blockchains that can do several second transactions. And they're 3 seconds, half a second. There's one that does a tenth of a second or so. But what we wanted was about 5 seconds, and 5 seconds lands in that kind of a sweet spot of usability. It means the blocks have a little bit longer to propagate, and the network can deal with them better. But it's also within the realm of anybody's patience for a transaction. For example, nobody has a problem paying with credit card, and the credit card transaction will go through in 10 seconds. So obviously people don't have a problem with 10 seconds. So we decided to make it 5 seconds. So the technology there that we're using for this is called stealth quantum proof of stake. And what that allows is these 5-second block times, and it's engineered in such a way that it allows cryptographically private transactions. Quantum proof of stake as a whole is a pretty interesting set of technologies that we've developed at Stealth. The coin developers, me most specifically, have outlined in the white paper and in our blog series. So the white paper can be found in the links in the description of this video, or you can just search GitHub Stealth Quantum Proof of Stake or Stealth qPoS and click on one of the top links on GitHub. And if you want, you can read about this. So the history of this document is I originally conceived of this type of system about, I would say, almost 2 years ago, or maybe over 2 years ago. And I kicked it around in my head, and then I eventually decided I was going to write a blueprint for the system, which was the original iteration of this white paper. And then I used this white paper as a rough reference to create the Stealth Quantum Proof of Stake consensus protocol. And once I did that, I had a working prototype. So I released the code for that prototype in about April 25th of 2019. And then based on that prototype, I rewrote this document or edited it to match what I had done in the prototype. Since that prototype was released, as anybody might guess, a prototype doesn't work as well as a production software. So what I've been doing since then is getting it production ready, running my own internal testnet that started with the protocol and has now evolved to what I think is pretty much production ready code. And that brings me to really the point of today's video, and that's to make the announcement that we will be starting this Stealth Quantum Proof of Stake public testnet in a few days. So this is going to give everybody a chance to check out the testnet, to see how well it works, to try to register one of these high performance staking nodes we're calling stealth nodes, or also somewhat colloquially referred to as stakers. These stakers or stealth nodes, you can register those on the StealthNet and get some coins, send them around, run a stealth node, and help us find problems, cause problems. Try to cause problems on the network with your nodes. The whole point of the testnet is to see what problems we can find and solve those problems before it does go to mainnet. With that said, I've just introduced the testnet, so let's check out the testnet. So what? Oh wait, before we do that, I just want to go to our web page here and just say that you can find a lot of information. Pretty much everything is going to be, for now, we've got it all on stealth.org. That's our whole website. So 7letters.org, stealth.org, and it's easy to type. It's written. It's actually written down here in the little marquee that I have for this video. And if you go to the home page, it tells you, of course, about what we consider our most our sort of a highest priority of development right now. At least our most prominent one is quantum proof of stake. We do have some other development going on. We're working on mobile wallet, desktop wallet, wallets that can be used with the Trezor hardware and other hardware devices. So we're definitely not limiting ourselves to quantum proof of stake development, but that's really our priority because that's going to set Stealth apart from any other coin out there and make us hopefully a go-to coin for private digital currency transactions. And you can read more about here. Is there anything to go here talk about? Not much, but what I do want to go to is the news. section. This is where you can get up-to-date information on what we're doing, and I try to keep this development blog updated. If I'm not blogging here, I've got interviews, releasing videos, we have updates. If we have something to say, we put it up here, and I love this page because I actually use it as a reference. So what this represents is, as I have worked on the prototype, and since then I've added features, I've made design changes, and pretty much everything except for the most detailed changes, at least the big changes, I've cataloged here and discussed. For example, I put in what I call certified nodes. Certified nodes help the network work better. They allow to, you can read about it here, but the short of it is you have a distributed network with a certain network topology, which makes it distributed, which means every node is connected to a certain number of nodes, and no nodes are excluded from the network, and the whole entire network is interconnected with no very important node in there that disseminates all the information as an authority. So there's no authoritative nodes in a distributed network. Here we have these high performance staking nodes. They are basically authoritative, but there can be any number of those. People can register as many as they want. So in that sense, it's distributed, and so we expect many people to have these, to be a safe level of conflict of interest of working, and so that provides competition and honesty on the blockchain. It's very much like miners, except Bitcoin has maybe 4 or 5 miners that control the whole network. This will have 30 or 40 staking nodes and potential different individuals owning these assets. So staking nodes are assets on the blockchain. They're called stealth nodes, and each stealth node, since it's an asset, has a place on the blockchain, and it can register what's called a certified node. And a certified node is one, it's not an authority. It's just a node that basically serves 2 functions. New nodes can preferentially connect to it. They know it's there, so they can try to connect to it and get established on the network by connecting to a certified node first, in addition to seed nodes. So certified nodes work like seed nodes in that way. And secondly, a certified node any other node will preferentially retain a connection to a certified node. And you're probably thinking, wow, that's kind of not very strong. It isn't. It's a suggestion. So in order to have a distributed network, you can't force anybody to connect to this node or not that node. They need to be able to do so voluntarily, and also you can suggest which nodes to preferentially retain a connection to, and these would be it. But the end result of this is after the network reorganization events that happen during the course of any cryptocurrency, the nodes people are turning on and off their computers. There's also network remodeling code. The network will reorganize over time. Connections will change. New nodes will come on. During that process, the certified nodes means that you're going to have just a core network of nodes that are superposed on top of the distributed network, and this core network will be a little bit more highly connected than the rest, and that will allow block propagation more efficiently in the core network, even though the rest of the network can connect in any which way they want. And if they think there's something wrong with the certified node, the concept of a certified node, say you have some hardcore blockchain distributed computing purist, they can just turn it off and connect to just random nodes. It doesn't really matter. So it's a protocol improvement that I think will help with the efficiency of the network, because it improves the connectivity of the core network, or should, if it's working according to how I think it should. And the latest blog post here was describing this protocol edition called extensible attributes, and I'm only going to mention it here because I'll talk about it a little later. Extensible attributes are information that each certified node can add to its own data structure and submit these to the blockchain. So they can, so a node can make a certain transaction on the blockchain that basically registers this information on the blockchain. So the cool thing about certified nodes is people know if they're connecting to the network, they know where to pick up their nodes, or their client will automatically. It'll just pick them up from a certified node. And this was the first use case for extensible attributes, where you can add a key, which in this case, these cases, a key is last name or first name or favorite number. And the value is, in this case, the last name is Doe, Jane is a value, 317 is a value, and stealthnode.example.com, which isn't a real node, that's also an example of a key, of a value, so key value pairs. And that's how extensible attributes work. And they will be useful for things that I believe are not part of the core consensus protocol. And like this is a network protocol level feature to have a certified node. It doesn't have to do with consensus. It helps consensus and then it helps the network stay networked and together, but it doesn't have any bearing on the actual consensus of the blockchain. So that's what extensible attributes are good for. And also there can be other extensible attributes, say for third parties. Say if somebody wants to make a light wallet and have their own nodes, they could have an extensible attribute with a specific key, and then people will know to connect to those nodes. So this is not going to be a heavyweight data storage on the blockchain. You will have to have bought a staker in order to have this option available to you. It's not unlimited. The keys are limited in length. The values are limited in length. Both are limited in which characters you can use. So, but I feel like it's going to be a very useful feature to have blockchain level sort of operational information on the blockchain, that people don't have to rely on any sort of central authority to get. They just rely on the blockchain, and if they don't, it's self-referential, and that it's the blockchain referring to it itself, and so the authority of the blockchain is the authority of the information. So, and they can ignore the information if they want. The consensus, that's why this is outside of the consensus algorithm. Nobody can add blockchain information that will influence consensus, which is really what you want the distribution of resources to reflect, is that distribution of consensus. So with that, let's look at the testnet. So before we do that, I just want to say what you're about to see is a very low level look at how quantum proof of stake works. And this is not going to be the user experience. And I'm not going to let the viewers forget that important point as I do this video. The user experience will be an easy to use wallet like Ledger Live, or even easier, or My Ether wallet. Those are kind of easy, but we aim to have even easier. I can't think of a really easy one. Hopefully ours will be the easiest ever, and people will preferentially use Stealth because it's the wallets are so easy to use. So I'm going to type commands. It's going to look cryptic. It's going to look crazy and nerdy. That's not what end users are going to have to do. They already don't have to do that. This is to get a look at the low-level protocol, and for anybody who might be interested in running a stealth node. And really this video is maybe for people who are interested in helping with the testnet, or really want to know what we're up to, and know that, you know, if they're not buying coins based on hype or YouTube, and they're interested in stealth, maybe to buy it, maybe just to follow the project. I mean, you don't have to buy anything if you don't want. Then you can check it out here and just see that we're really up to something that I think is pretty cool. So for some reason, the wrong windows came up. Let me see if I can bring the right ones up here. Hopefully that came out all right. Yeah, I think that's okay. So here we have, sorry about that. I thought I had this laid out already, but I don't think that was too much of a distraction. So here we have the testnet. And like I forewarned you, it just looks confusing. But I'm going to show you around. I encourage anyone who's already gotten this far to just, try to see what I'm talking about. I know it might be a little technical, but if you can follow it, I think there's some cool stuff here for anybody who's interested in learning, especially, if you're investing in blockchain, learn about what you're buying, right? You don't just buy on hype. And this is how you do it. You got to get down and dirty and see what's out there on the lowest technological level, because people think about blockchain like this. People say, well, what if you could have bought, your piece of the internet back in the 1990s? I want my piece of the internet because I know it's going to be huge. Well, nobody could buy a piece of the internet. Cryptocurrencies, I think, is this once in a lifetime opportunity to buy a chunk of the technology. But isn't it important to know what you're buying? And so I think if people would have bought the internet in the 90s, they may have read some of the specifications, learned about HTML, and said, yeah, this is worth buying. I mean, the people who did that would have been on top of it and bought it up. And they probably did. They worked with the technology and many fortunes were made. But now there's an opportunity to buy cryptocurrencies. So try to check it out and see if you can get anything out of this video. I think it's pretty interesting, but of course this is all my design. So here's the testnet, and the testnet right now consists of 4 nodes. It's kind of small, but I'm just one guy working on the testnet here. So I have 4 nodes that I'm running, and you can see there's some lines here and some confusing, numbers and letters scrolling up. It might look pretty cool. Might look something out of the future, but this is really what's happening on the testnet. And each one of these, what I've just highlighted here, you can't see the whole thing. I guess I could move this window over. I'm just going to move this window over so you can see the entire block hash. Maybe I can move it back in place too. So there's the whole block hash that I just highlighted. BC260, you're probably thinking, please don't read that, and I'm not. But that's a block hash. So each one of these represents a block on the network. And if you're into cryptocurrencies, that cryptocurrencies are, most of them use blockchains. So each block that comes out is a new block on the blockchain. And let's scroll this baby down right here. And when this bottom line here is the most recent block, you can see, if I can do it fast enough, C49, 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 every single node has the same most recent block, which means they're all on the same chain. There are 4 nodes here. Each one of these panels, like when I hover over it, it highlight changes. See, this one is one panel, and that's a panel, and that's a panel. Each one of these are a node on the network, and they're named T1, T2, T3, and T4. T1 stands for testnet node 1, and so on. Each one of these nodes is running a stealth node, which is a high performance staking node. So it's an asset on the blockchain that allows you to sign blocks. So each one of these nodes are signing blocks, and this is the extent of all the block signers in the network here. So right here, that one just signed a block, then it went here, here, and here. We can, maybe I'll just hover right here. I'll just hover right here, and whenever a block comes here first, let's just try this, because this, oh wait, no, this one signs the most blocks. So we'll hover here. And when that moves up before the other one, okay, that was 2 was first on that one. I just want to do it. There we go. See, that one signed a block, and then that block went to all these other ones. So you have to be watching. And if it's hard to like follow or something, don't worry about, whether or not you're actually watching the blocks. And just a new block comes up in one of these, it propagates to the rest. So this node is running a single stealth node, high performance staking node. This is running one of those assets. This has 2 of those assets. So this will sign 2 blocks for every one this signs. And So there's 1, 2, 3, 4, 5 staking nodes in this network. First thing I want to do is this one has 40% of the power, consensus power in this network. It's as if it has 40% of the hashes on the Bitcoin network. It's the same sort of concept. Of course, this is not mining power, it's staking power, but it's the same concept. So if I go to that node here, it's T3. If I go to that node in this one, pardon all the extraneous info here. I'll just scroll that out. That's just me working. I'm gonna kill this node. I'm gonna stop 40% of the network if I'm in the right place. So now it's dead. You can see that this will stop scrolling. With this, one of these guys will make a new block. Now blocks are going to be slower. We just lost 40% of our power. So it may take a couple of seconds for a new block. See, now that block 4C3, it went to all these guys. This guy's dead. This is not even working anymore. So we'll let him have a couple of blocks here. So the network is actually moving along just fine. You can watch each one of these nodes, like who's going to go next. Got to be fast. It goes in every 5 seconds. Well, it won't go every 5 seconds now because these guys are out. So one of the, well, you can just see that each one of these guys is working. First that one, then this one, then this guy's probably going to have a block pretty soon here. So you can see that each one is making blocks, except this guy because he's dead. But let's just fire him back up. So this starts the node. And of course, what we have to do is, this is a command that just is going through the log file, and every time it says accepted or orphan. Orphan is kind of bad, I guess. It's not really bad, but it's not consensus. And boom, this is right on there, and this guy is going to be making blocks pretty soon. He'll be the first one in just a couple of seconds when his time comes up. There we go. Or her time, if you consider a node anthropomorphically feminine. So now I just demonstrated that the network can lose 40%. It can fraction into 2 parts, and if one part retains over 50% of the hashes, it'll just keep on going. So this is actually a good way to achieve consensus. If I had a way to get this guy on its own chain, you would see that it would reorganize and join all these guys here. So let's I hope that gives a sense of how the network is laid out. I have all these nodes up here, T1, T2, T3, T4. The number afterwards is the number of CPU cores at each node, so I can remember whenever I'm doing various things. But just look at, so right now I'm controlling this guy. I'm typing commands into him, the one with 2 staking nodes. And so what I can do is just, you can see also that I'm on T3 up here, is issue this command. So here's a quiz. Will an end user who's just using this stealth to use coins to, say anonymously buy a coffee, will they ever have to type a command like this? No, right. Everybody who said no, just give yourself a pat on the back. They're never going to have to type a command like this, okay? So what I'm doing is I'm showing you the lowest levels here. Just, get qPoS info. So here we go. This is a command that tells us what's going on with the quantum proof of stake network. It's not all the information about the blockchain. In fact, there's very little blockchain level information here. It's protocol level. It tells you about the quantum proof of stake. And I'm just showing you a little bit of around here to show you, how it works, I guess. So for example, this is blockchain level. What block height were we on whenever I typed this command? 41,620. So this network has had over 41,000 blocks. The latest block for that height was this. So that's some useful information. There's a lot of other useful information that I won't go through. This is called pico power. So this is 1 times 10 to the 12th units of power. So there's one, so all the power is on this chain. So if the chain fractions say into 50%, oh, I could kill this node again and show that this goes down from 1 with all those zeros to 1 less digit, and this will only be around 6 with all these zeros, which is 6. So this is 100% and this 60%. And it's called pico power because that's an implementation detail, but just think of it, if you have all these zeros and 100 at the beginning, it's 100%. So all the coin staking nodes are doing just fine here. Here is what is the Q. So the way to achieve really fast blocks that come at highly regular is to actually schedule them. And scheduling means you know exactly when a block is going to be, you know exactly who is responsible or which high performance staking node is responsible for creating that block. So in this case, you have a queue of five staking nodes. As I mentioned, if you look in this panel, 1 staking node here, 2, 3, 4, and this one, and then 5 in the bottom. So there are 5, and they're shuffled in random order. I know this doesn't look terribly random, but it is. Sometimes random numbers don't look random. So 1, 3, 2, 4, 5. And you can just, I'm going to reissue this command so that you can see that changes, it changes randomly. So it's 5, 1, 3, 2, 4. So that's more random looking this time. And so what happens is in a queue, each staking node they go in rounds. So in each round in the queue, each staking node is giving a slot. So here's the first slot. Also, the numbering starts at 0 because it's a computer science thing, right? It's a computer thing. It always has a start at 0 unless I think you're Fortran. So 0, slot 0, slot 1, slot 2, slot 3, slot 4. Each one of those slots is assigned. Each staking node is assigned those slots randomly. So this 5th node had the 5th staking node, which is run by this guy, has the first slot. The first staking node has the 2nd slot. This is where the first one is in this guy is one of these two, and so on. And I'm going to do it. I'm going to run the command one more time, just to prove that. There it is, 2, 1, 4, 3, 5, totally different from the other two, completely random. Each time there's a round, we're on a new round now, and the rounds are counted here. The round height is really, really high because it just reflects months and months of testing and not making blocks. So it still has rounds even if it's not making blocks. So each round you get a new one, and then they sign them in order. They have a time they're supposed to do it. These are This is a computer way to keep time here. You can see what time that is supposed to be with the program, but that's today. And then the beginning of its slot is that. The next slot starts 5 seconds later. 52 minus 47 is 5. 57 minus 52. So each one goes 5 seconds later. And then after a round, after this guy signs his block or not, and after this time right here, a new round is created, and they have to sign in that round. And here we have the stakers section. This describes everything about these stakers, which we call stealth nodes formally, which I call high performance staking nodes here in the video so people know what I'm talking about. Each one of these stealth nodes is listed here. So here's the first one. Here the indexes actually start at 1 for implementation reasons that are too deep to go into here. It's called stealth rules. When you register a staker, you get to name it whatever you want as long as that name is available and conforms to the naming rules, which just are related to what characters you can use where so that the names are actually readable. It is qualified, which means it hasn't misbehaved. It's enabled, which means it's on. They can be disabled and enabled. And then the keys are here. Owner key, delegate key, controller key. These are different authorities related to it. Of course, the owner is the person who owns the staker. They can do anything they want with it. The owner can assign a delegate, and the way you assign things and on a blockchain is with a public key. So in blockchain, and if you're buying blockchain, it doesn't really hurt to know what you're getting into, right? A, a blockchain has a private key and a public key for each, for basically for every authority out there. Here's an owner authority. So the public key, the key everybody can see, this isn't a secret key or anything, is this long number. This is a number, it's in base 16, where instead of 10 different numbers, you have 16, and the final 6 are A through F, okay? It's more amenable to computers, and so they do that. They make these numbers in computers. Also, so you know you're not looking at a quantity, you're looking at something like a private key or something like that. So the owner authority is here, and authority is something where you can sign for that authority with the private key that nobody else but you knows about, so that you know that private key gives you complete authority over that. So the way you do it in blockchain is you say, oh, the delegate for this has the key here, and the delegate who has a private key for this key gets to sign blocks. Now, in this particular staker, the delegate is the same as the owner. So the owner owns it. They can do anything they want. They can even sign blocks, but they have to assign themselves as a delegate to do that, which is the case here. The delegate, their sole job is basically to sign blocks. They can do some other things, like they can actually register a certified node. So they have other things they can do, but their primary thing they do is just sign blocks. And then there's a controller key, and that is got one function. Is a controller key can turn on or off the node. So you can imagine, let's say at some point Stealth is a very valuable blockchain. I know everybody would love that to happen. And people, what they do is they own stakers as assets, as capital. But just like Warren Buffett isn't out there sewing sheets together in his Berkshire Hathaway factory, he's got people delegated to do different jobs. There's the guy who's running the factory, there's the people who are running the sewing machines, and so on. Berkshire Hathaway was actually, I think it was a textile company to begin with. But he doesn't actually go out there and do that stuff. He has other people do it. So you can own your capital as an owner, and you can have a delegate assigned to sign blocks. Now, you also want somebody who will police the delegate. You can also delegate that authority to a controller. So the controller can have no vested interest in the delegate. They cannot even know who the delegate is as a person, so it would be very hard to cooperate with them. You can have a higher level of trust in the controller than the delegate. And if the delegate is misbehaving with your staker, the controller can detect that with a computer or something and just shut it down. So that's the point there, is you have not only delegation, but you actually have oversight for failover type situations that require a node to be shut down before it's brought up under a new delegate or under a new system. So this is actually absolutely unique to blockchain. I've never seen anything like this. It really turns the blockchain into what it should be, and that is an asset. Ownership rights on a blockchain in terms of consensus rights should be an asset that should be able to be used as capital, and that capital should have be able to be monitored, controlled, transferred, delegated, you name it. So these were the three authorities that I could think of that would be absolutely essential for such a system, and here they are. And I want to talk about delegates and how delegates, how do owners pay their delegates, right? When Warren Buffett pays his Berkshire Hathaway guy, they have a contract, and he's probably got direct deposit in his bank account. How does blockchain do that? Well, blockchain can do that with smart contracts, and there's really actually no limitation on where you can put a smart contract. And actually, if you boil it down, Stealth Quantum Proof of Stake has this smart contract in it where a delegate can assign blocks for an owner. You know, I'm going to scroll down here because this is a good example of one that has a different delegate key from an owner key. So this guy, this key starts O2AC and the owner key starts O2B2. So the delegate key is O2AC. So this owner O2B2 can delegate to this the person who controls who's this delegate O2AC, and then when can the owner pay it? Well, in every other blockchain that I know of, I'm talking even Tezos, where you can have somebody, you can delegate your authority to somebody. Those guys have to make payouts. They got to go at the end of the. I mean, seriously, this is the state of affairs in blockchain. It's a real head scratcher, in my opinion. Is like, why aren't these the smartest guys around? I mean, why aren't they putting this in? But the idea is the delegate, the blockchain handles payouts to the delegate. So the delegate signs a block, and when that block is created, the delegate is credited by the blockchain, by the protocol, as a type of smart contract. The smart contract is hard-coded into the protocol, but it's still a smart contract. As the smart contract dictates, the delegate is paid out by the owner when the block is produced. And so the owner could have 10 staking nodes and 10 different delegates. We hope that's not the case. We hope staking nodes are more distributed that. But it could be the case, and the owner would never have to have an accountant go through and say, okay, we're going to pay out this delegate this much and that delegate this much, and we're going to dock him for missing a block here. It's all handled by the blockchain as it should be, and as it isn't in any other blockchain system that I know of. So anyway, either we're way on the ball here at Stealth, or everybody else is just dropping the ball. You be the judge. So we have some other things here, just some stats for each of these. How much Stealth has this delegate earned over its lifetime? How many blocks has it produced? 7,458. I guess it's been off for a lot. It's missed a lot. It's missed a lot because remember, the counter and the rounds keep going even if the whole network shuts down. It's interesting that way. There's a memory of that very first Stealth block, and even if every node shuts down and they come up, it still calculates the rounds and the number of blocks missed. Then there's the number of blocks assigned, number of blocks that it's actually seen. And then there's the number of blocks missed. So number of blocks seen is the number of blocks probably more closely related. I have to go remember what that number is. I wish I could remember it right now, but it's an important stat. So there's several nodes, and this one has a certified node. So I did a extensible information transaction, which I also call a metadata, which is a misnomer here, but I just kept the name because it's short. A metadata transaction, or an extensible information transaction, where it registered a certified node, where this is running. This one has a certified node, and there's the fifth one. And so then the last thing that gets listed here are the balances. So if you will, we can scroll up here and just check out this one that had the staker delegate. So its key starts O2B2. The owner key starts O2B2, and this delegate key starts is called O2AC. Starts with O2AC. So here they are here in this ledger. This is a ledger of balances for the quantum proof of stake network, where the balance, say, of the owner, remember that was O2B2, is 249 Stealth, and the balance of the delegate right now is 20.9 Stealth. So obviously this delegate has not been getting paid the full block reward. But if you will notice, I can update this because I'm sure this guy's minted a block. So 20.93 for the delegate and 249.1. Maybe we can remember that. So they've gone up from 21 to 250. So every block, these balances are updated as they should be. But this is a ledger, and these actually, in a blockchain, like Bitcoin and Stealth uses this system too. These are called the way you spend money. The money actually doesn't take the form as ledger entries. The money takes a form as what's called spendable outputs. Like you can actually have they're like traveler's checks. So this is not a traveler's check. This is a ledger. And the reason we use this is for efficiency. It's so that, you know, the payout for every block, if you were to have a delegate and an owner, you know, every block you'd have to have 2 transactions recorded in the blockchain. So you're doing that every 5 seconds, a mandatory 2 transactions. It's just it's a waste. It's way better to keep this information as a registry, and then for people to spend it on the blockchain like a normal spend is just ask them to claim it. So what I can show is how you claim balance here. In fact, I want to demonstrate that. I'm going to try to see if there's anything else that I'm forgetting here, but probably not. So let's try, let's first just, what we can do is make a claim for, like, say, you know, this guy. He wants to claim his full balance at the right now. So the first thing you have to do is remember, okay, let's go back to that quiz. Does anybody think that an end user is going to have to type these kind of commands? Right. Okay, good. Great. For those of you who missed it this time and got it right the last time, I don't know what you were thinking. But right, end users don't have to type this. Only stealth node operators would have to type this, and probably only in early iterations of the protocol whenever we haven't gotten more convenience built into it. But just follow along to see how this works so that people can understand kind of how things work with quantum proof of stake. So the first thing you do is you have this address here. This is a public key, and a public key. Got to actually make a command. Validate pub key. A public key actually corresponds to an address. This public key, O2B2A, corresponds to this address that you can send to MYR. So if you send Bitcoin somewhere, you know how you send it to, you know, something that starts with a 3 these days, and sometimes you'll send it to something that starts with a 1. Those are Bitcoin addresses. Litecoin addresses, I think, start with an L. Ether addresses start with OX something. So this is what the address takes. Each one of those is actually a representation of a public key in a public-private key cryptography system, and this is the public key. And this is a compressed public key, but it's a public key that represents the full mathematical value of the cryptographic public key. And you can modify this in such a way that you can make an address that looks like this. So you don't send to this big long number when you send coins. You send coins to this number. So what I'm going to do, I'm actually going to send from another node just for fun. I mean, this is just purely for fun. I got to say how much. Let's just make it 0.01. What's the significance of this value? That's the self fee. So I'm sending exactly enough to do something. So we can go over here to this node we're working in. Oh, I didn't. That slows me down. That's more confirmations. So it's already had 4 confirmations since I sent it. Remember, I just sent it here, and I came over here and I fumbled around a little bit, and I talked about the significance of 0.1. In that time that barely went by, there were 4 confirmations. Apparently, that was about 15 seconds. Could have been 15, could have been 20. I don't know. If we were to do that again, you'd see that in this amount of time, where I was talking about the amount of time I was talking, there were 8 more confirmations. So Bitcoin won't have 8 confirmations for nearly 3 hours, I think, right? 60, it's a lot. So Bitcoin has 6 confirmations per hour. Okay, so yeah, an hour and on a good day, an hour and 20 minutes for 8 confirmations. I mean, that's a, but here it was 8 confirmations, and now it's already up to 15 confirmations. So it doubled while I was talking about Bitcoin confirmations. So these are really fast confirmations, right? But now this node has this 0.01 stealth to spend. And you can look at, since you invest in crypto and you're watching this or interested, I will describe, so you know what you're buying, I will describe what a transaction looks like. So transactions have a transaction identifier, TXID. That identifies uniquely the transaction. And in this transaction, you have a certain amount of coins you spent. That's called the inputs. And then when you spend those, you make change. And then you send those to some address. So here I sent it to myself, and the change. So this must have been 16.756, which is 16.73 plus 0.01 plus 0.01 for the fee. That was the input. We could actually check that out and see if I'm right. If you can look at this, we could look at this transaction here, but I'm not going to. Just take my word for it. You can play with this whenever you're running your own testnet node. So here we have a 0.01 stealth sent to this particular address, which is this staking node, which is this high performance staking node, also called a stealth node, also called a staker. We can use that input here, identified by this coin. This is what this is called, a coin. Even though it's not one whole coin, it's called a coin in blockchain parlance. This coin of value 0.01 stealth is uniquely identified by the transaction ID, and this number here happens to be 1. So this would be D7E1 blah 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 dash 1. Okay, and dash, it starts at 0, and this 16 would be D7E1 yada yada dash 0. That would be this one. So this one is this transaction ID number 1. These are called outputs. So this is coin 0, this is coin 1. This coin 1 has a value of 0.01 stealth. This, if we can spend this, here's some Socratic type pedagogy here. If you can, true or false, if you can spend this coin, you prove that you have spending authority for this address that it was sent to. That's long enough to answer. Yes, the answer is true. You do prove it. So if you prove this, that you have spending authority on this address, then you prove you have spending, if you have proved you have spending authority on this address, because this address is just another representation of this public key, you prove you have spending authority over this public key, which brings us up to the balances, which means you're going to be able to claim this balance. All you got to do is couple spending that 0.01 to this address, which corresponds to this key. Then you can claim the balance at this key. Just couple those two things together, and you've proven your ability to claim the balance. So the way you do that is you do a claim. So I'm just going to get help here. Help. Claim qPoS balance. And that's just the form of the command, so I always need that to remember exactly. I probably should have it memorized by now, but you know, I don't memorize things very well. And the amount, okay, it's gonna give me an error, but I'm just gonna accept this command. Actually, I didn't type a command. I forgot to do the help claim qPoS balance. But the amount, I just want to get the amount we want right here by doing get qPoS info. It is, we're claiming this balance. Now I have to type the name of the command. Oh, claim qPoS balance. So I just claimed that balance. Now let's check it out. It's probably already had a confirmation, so you can actually get qPoS info. And it's already signed a block, so it's already signed a couple of blocks, 2 or 3 blocks since I checked what the balance was. But it says when was the last claim. The last claim was just a few minutes ago. Now that ledger says, so on mainnet you can only claim once every day. That's so people can't spam the network with claiming every block. They gotta wait a day. And if you're in business, you can wait a day to get your day's worth of earnings. It's like you can wait till the end of the day to count your register, take your money. So it's the same concept here. You have to wait one day from this time. You can actually see what time it is using Python. Import time. Time.ctime is a command. There's probably an easier way to do this, but I don't know what it is. And that just says Friday, September 6th, 11:57. That's a UTC time. That's That's a universal time. So they have to wait until Friday, September 7th at 23:57:57, 2019 to make another claim on the mainnet. On Testnet, you can claim as many times as you want, just because it'll make debugging things easier. Okay, so by now this transaction, if we've should have a lot of confirmations. I don't know how many to have, maybe 10. And it has 21 confirmations. You can see that the claim itself propagated to the other nodes as well just by typing it in here. There it is. Now it has 23 confirmations. It's been 2 since I typed this command. So the last thing I want to do in terms of a demonstration here is just spend it. So this is going to get just a touch more complicated, but it's pretty easy. It's just a command that you have to run. So one thing you should notice is if you notice, I claimed. I'll just go up and show you what I claimed here. Hit Control C. Now, I didn't actually enter that command. I just if you hit Control C, it doesn't enter and just goes to a new line. I claimed 2250.844 and that 073, and that's what this was for. So there was no change included in that transaction because I sent exactly enough for the fee. If you remember that 0.01 was exactly enough for the fees. So this is exactly the same amount of coin here as this. So, but I can spend this. So what is this? What coin is this? Well, this coin is transaction ID FOD something -0. So that's the transaction that uniquely identifies this coin that I can spend. And it's a claim, but claims are now spendable just like any other spendable output on the blockchain, just like any other coin. How do we, the only thing is just to prove I'm spending it, I have to specifically spend this coin, and that's a semi-complicated transaction that I encourage everybody to look at just to see, how things work in this technology that you're interested in and maybe purchasing. Look after your money by understanding what you're investing. So Stealth Coin, the thing is create raw transaction. I want to help. I need help on that. As you can understand, when you see you can see what it takes to make one of these. You'll see that I need help. Okay, so this is the form. It's create raw transaction. Don't forget to type the command, or else you'll just have to put it in later. Now, all this stuff is pretty crazy. I'm going to try to make it look breezy. Then this, you have to say TXID like that, and then tell it what transaction. This is how you uniquely identify that coin. First, you need the transaction ID. Then you need this is called a VOUT. This index here, 0. So that transaction ID and that VOUT is 0. There's a reason they call it that, but I won't get into that. And then that's this term here. So create raw transaction, tell it what coins you're spending, and tell it where you want to go in this form here. So where do I want it to go? I guess I'll send it over here to node 2. He's looking a little impoverished. I'm sure he's not. Okay, so that's where we're sending it to. Oh, time for a quiz. First, does everybody know what quiz it is? Second question on that, if you didn't get the first one right, is will end users ever have to type anything like this? Okay, everybody should have gotten it this time. No, they wouldn't have to do this. Okay, and then we're going to send them, we'll send them the whole thing minus a fee. Well, that's not it. It's this coin here. And oh, got to type it in the correct format, and then that's the amount. We got to account for the fee. So the 4 goes to a 3. Not that 4. So if you 250.834 came from 250.844, but I had to put the fee in it so it didn't reject the transaction for not having enough for a fee. That's how you do it, and that's the raw transaction. This is how you do it. This is how you absolutely specify which input you're going to spend, or which coin you're going to spend. There's no other way. Again, I do the quiz, but I think y'all all know the answer by now. End users will never have to do this. Sign raw transaction. And of course, nobody will ever have to use this. Usually computer programs do this. I'm just doing this to show that the claims can be spent. That's the main reason I'm doing this. Looks like it completes. So it's signed to the raw transaction. When you sign a raw transaction, you can send a raw transaction. Oh. And that should give me this is the transaction ID. And I forget who we sent it to. Was it this guy? Yeah. First, we can just get transaction. And he's already confirmed it 3 times, so is the whole network. And of course, there it is right there. And if you don't believe me, I do these. I can just type it here. See, 3E4. That was the latest transaction where we received all that. So the balance from the registry was claimed and sent to somebody, and in the future you can convert this to anonymous coins. The registry is not anonymous because you have to keep track of who made it, but it doesn't matter. You can always claim it somewhere, turn it to anonymous currency, and then send it around when anonymous currencies are put in. So something I forgot to do earlier, but I want to do right now, before I wrap this up, is just show you the timing on the blocks, how regular the blocks are. So the way I do this is I have this little stopwatch here I use. You can see I started the stopwatch right whenever I saw a block here. So usually a block will hit here. You may not be able to tell right before this turns to something divisible by 5. So every time this is 0 or 5 over here, there'll be a block just popping up right here. 7, 8, like this. And now. So these come out this down. See? So that's how that works. So you can sit here and watch this, which is one of my favorite hobbies, is to watch my Testnet just knock out block after block after block right on time. And so that, if you think, oh, you can just program a computer to do something right on time. This is a distributed system. These guys may not all have clocks that are perfectly synchronized. And they may go offline and not see a block come in. They may not know really what time it is. And it's really hard to keep time. And Stealth has something, and I wrote about it in a blog post, so you can scroll down and find it. Maybe we can put a link up. It has something that's called an asynchronous network clock that's not in any other cryptocurrency. It allows a network to basically run under very harsh conditions that tend to drop nodes, fragment the network, and still retain this sort of universal clock, and for everything to be on time. So something happened here. This was cool. Uh, this guy felt like he got an orphan, but now they're all back on the same chain. So one of these nodes must have gotten dropped. This is perfectly normal, but it's nice to see here. Um, it's nice to see that whatever network. Remember, oh, I should say these nodes are horrible. Like I bind the cheapest nodes from the worst provider, except for I think this guy is pretty good. But this one, I think one of these is really bad. This one is not the bad one. I think this one is one of these two is really bad. Like horrible network latency, drops connections, it's just horrible. So that's why you get this. But the point here is not you don't want to avoid things like this. What you want to be is robust to things like this, right? If people are writing protocols to avoid problems, they're I think if they're using blockchain, they're taking the right approach. What a blockchain developer needs to do is embrace problems, look for problems, and find a way to be robust against problems. If you do that, you're going to end up with a more robust system, and it goes down to this clock. And we can see now, like, did it really recover from... Just a minute, I meant to hide this guy. Did it really recover from that orphan? I don't know who made that block. I guess we could find out. If I guess it was up here. All you have to do is say, oh wow, well maybe everything went to... Everybody wouldn't be taking on blocks if it works. Still get qPoS info. And you can just go up here and see what the pico power is. So yeah, everybody's participating in this. So the power, the pico power, which is units of 1 times 10 to the minus 12 power of the total power of the network, is maxed out, which means everybody recovered from this orphan. I don't know what happened here. You know, a node got disconnected, created a block while it was disconnected according to the protocol, and the network rejected it because that block was already produced by another, or skipped by the network. But the way this works is these nodes continue to make blocks. So this is not... The orphan blocks are to be expected in regular proof of stake. They arise from network. They actually arise from network latency as well. And here they will only arise whenever you have something really wrong with the network. And I've purposefully kind of designed this network to have plenty of things wrong with it all the time. This network is actually running very smoothly with pretty poor nodes that are constantly getting disconnected from each other. They're constantly doing this remodeling, and I only have a couple of registered nodes that I just registered those to kind of get the network going. I could take those down and it would still be robust. With only this many nodes, it could completely fragment. At this level, it would break apart. There's only a few nodes and they're all very underpowered. Even my best node up here, number 1, is underpowered for this application. In general, I mean, I guess it's good enough for this, but in the future it'll probably be a little underpowered. But each of them are underpowered, and a couple of these are on really bad networks, and it's supposed to break up, because I haven't been testing. Can it run? If everything is just right. I've been testing. Can it run under pretty miserable conditions? A low number of nodes and very, very many network problems, and even the computer itself will actually have problems. Like it will have some process kick in. The single core guy, whichever one it is, I think number 2, will have a process kick in. I'll have to deal with that and actually get behind it that way. Same thing here with number 4. It's pretty underpowered, even though it has 2 cores, and the network on it is just atrocious. This guy is just, he's bad news. So let's see. Yeah, that's what I was hoping to show here. I could just say one other thing um, about this guy running two nodes. Uh, the first thing I should say as a responsible developer, it's you can get two staker nodes if you want, two stakers or stealth nodes. You can buy 2 or 4 or 10. It's your money. Stealth is a kind of a freedom blockchain. That's the philosophy behind it. Whatever you want to do, go for it. But it's preferable, if you're thinking about running nodes, maybe not on the testnet, but on the mainnet, if you could move them to their own hardware in different maybe geographical locations, that would be preferable. With that said, though, if you want to buy 20 staker nodes and put them all on the same computer, as much as it would make the developers and the community cringe and may not be the best thing to do for your investment, it's your money. Go ahead. We don't have a committee. We don't have a delegated proof of stake type committee thing with control by somebody who claims they're not controlling it but actually are. We don't have a committee like that says that you can't do whatever you want to do. We will never vote your rights away because we can't. This coin's been around since 2014. It's been on the exchange. Most of the coins out there have been cycled through an exchange several times. By one buyer buying now, the other is selling, maybe for a profit, maybe not. Another guy buying, and so on for years. So they've been mixed up. They've been redistributed. It was mined into distribution. So whatever you want to do with your money, you can do. We're not a central authority who's going to make a committee, who's going to pretend we're doing it for governance issues and tell you what you can and you can't do with your money. And you're going to be running a node on a high performance network that where you have really nice block times. I mean, there is no waiting to see if it can confirm before the deadline, that you're trying to beat online when you're trying to make an online purchase. It's just gonna work. So yeah, that's my pitch. The summary is private testnet. It's ran its course. I can't find any more bugs this way. I need more people, more nodes, more variables. I need more problems to solve to make it even better. That's going to require help from the community. Where else do you get to just to create problems as part of your participation? And then on top of that, yeah, this thing is running spectacularly. It's really pretty amazing in my book, and I really can't wait to get it onto mainnet after we get a privacy put on top. So from here, we're gonna run the public test net where I'm gonna be less involved day to day debugging this because I can't debug bugs that I don't have. I'm gonna be developing some features on top of it, some improvements that I think are not necessarily related to the core protocol. And then we're going to be working very hard on privacy. And then we have some developers working on mobile wallet, desktop wallet, Trezor support, and some other, maybe a browser-based wallet, but not a web wallet, where it's one of those where like you keep your keys there, like MyEtherWallet. But yeah, I guess I'll sign out now, everybody. I hope to see you on Testnet.